we're going to go over a topic. This is normally called primary trig ratios. Okay? Primary trig ratios deals with three different types of ratios. One is called sine, one is called cos, and one is called tan. Okay? Trig is a form of mathematics, deals with measuring circles, has periodic functions. We're going to focus on the triangular part, measuring triangles. And ratios, if you remember, are fractions. And that's where these three things come in. We're going to give, in this case, we're going to be looking for essentially measuring triangles. And in triangles, we have really two different types of variables we can measure. We can either measure the internal angles. So we have 1, 2, 3 internal angles. Or you can measure the sides of a triangle, which in this case would be these areas. I'm guessing this is a scalene triangle. It kind of looks isosceles, but those are the three different types, okay? When we're measuring angles, we're going to use sine, cos, and tan, okay? They represent essentially a function or a really big equation that we don't go through the process of calculating. We use a calculator, but we do use it in our algebra. It helps us organize things. This here is a new symbol, okay? It's known as theta. It's technically a variable. You may see people write sine x instead of theta, or y, or any other variable. It's from the Greek alphabet, and it's usually set up to represent an angle. So you may or may not see it. We're going to work with it. Think of it as a symbol. I could use anything for a variable. I mean, my variable could be this lovely happy face or this very angry face because you don't like trig. All of those can represent variables. We're just going to happen to use that symbol there called theta, okay? So we have theta, and the way this formula works is sine theta is equal to a ratio. Cos theta is equal to a different ratio. And tan theta is equal to a different ratio, okay? And they're all in reference to the triangle, these sides. I'm going to get rid of that sine x. So we have to know how to name our triangle. And it also depends where theta happens to be in this case. I'm going to do this. I'm going to say this angle down here is the angle theta, okay? Sine is equal to, it's called the opposite side of the triangle. Opposite. Over the hypotenuse. You know what? I don't remember how to spell hypotenuse. I'm going to just mumble the letters there. Cos is equal to adjacent. Here's my way of copying out short form. And then tangent is equal to opposite over adjacent. Okay, so we essentially have three different sides. I'm going to use a bit of a highlighter to help us out. We're looking for the opposite side of a triangle, and you'll notice that happens in two of these. And in reference to theta here, this would be the opposite side. If we were to draw a line directly across, that would be opposite of the angle we're referring to, okay? Another side is known as the adjacent side. And the adjacent side has to do with the side that's touching the angle. And in this case, there are two of them, but we're going to refer to this side. And there's a reason for it. And the reason being is because you'll notice this is a very special triangle. In fact, primary trig ratios only work for this type of triangle, and it's called right angle triangles. Triangles that have a right angle. This one has a right angle down here. So the side opposite of the right angle is always called something special. And in this case, it happens to be called the hypotenuse. Okay? So that's why this side is known as the hypotenuse, and therefore this other is the adjacent side. So just keep that in mind when trying to label your triangle, whatever angle you're dealing with, even if they call it x or theta. The opposite side is easy. It's the one side that doesn't touch the angle. And then you obviously have two sides. In order to make an angle, you need two sides of something. One of those sides is the hypotenuse, and then by deduction or by default, the other side is known as the adjacent side of the triangle. Okay? When they write these, they usually have a short form for them. They'll say something like sine theta is equal to opposite over hypotenuse. They'll just use the initial letters, O over H. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. In fact, they'll really short form this, and they'll use a, this is technically an acronym. So yeah, it's an acronym. They use this to remember it. SOH CAH TOA. And all that means is sine is equal to the opposite divided by the hypotenuse. Actually, I'm going to take that out of there not to mess it up. I'll put the division above, okay? Cos is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So they call it SOH CAH TOA. That's just a way of remembering each of the three ratios. These three ratios, you kind of have to memorize how they're set up in order to use them. But once you know how they're set up, you can solve any right angle triangle as long as you have three pieces of information, okay? And one of those pieces of information is the right angle in itself. So really two other pieces of information. So this is what we're going to do. I'm going to make up a triangle here. Okay, and we're going to say that this is 90 degrees. And we'll say this side here is 3. And this side here is 4. Okay? And the rest will be unknown. We won't know anything else about this triangle. So what we're going to do is we're going to try to solve every other piece of this triangle using these ratios that we have. So the first thing we have to do is choose an angle. We don't use the 90-degree angle. We don't use the 90-degree angle when using our primary trig ratios. We use one of the other two. And it doesn't matter which one. In fact, just to show that, I'll use the one at the top here. I'm going to call this angle theta. I'm going to give it that name for now. Okay? So that's my theta. So I want to find out what the hypotenuse is equal to, which is this side here, because I don't know. So in this case, I can use either SOH CAH TOA, so I can use sine, cosine, or tangent. I may not know which one to use yet. So what I'm going to do here is I'm actually going to set up all three and see which one helps us isolate for that. So remember, we get sine theta is equal to opposite. Okay, well, what is opposite of this? Opposite happens to be, in this case, the number 4. So we have 4. I'll put that in black. That's hard to see. I'll just use the highlighter there. There you go. This is our opposite side. We know the hypotenuse. It's the side we're trying to find. And we happen to know the adjacent side too. It's 3. Okay, so we're going to try to set these up. I have opposite is 4. Hypotenuse is unknown. I'm just going to call it h. Okay, I could call it x again, but I'm just going to use the letter h to represent that variable. We can set up cosine, or cos theta, is equal to the adjacent. Well, the adjacent side has a measurement of 3. So I can say that's 3 over, and h, we have no idea. And tan theta is equal to opposite, which was 4, over adjacent, which is 3. I have a ton of information about that one. But remember what our goal is. Our goal is here to find the hypotenuse. Well, if we take a look at this, I don't actually have enough information to solve for any of them yet. These two equations here, I have 2 variables, theta and h. I need to have the information for at least 2 and have only one of them missing. I have 2 unknowns, so I don't have enough information to use sine, so I actually can't use sine yet, even though hypotenuse is a part of it. Cos, same idea. I have 2 unknowns. Even though hypotenuse is a part of it, I can't use it to solve. Tangent, I only have 1 variable, but the hypotenuse isn't part of it. So it just so happens I'm going to actually have to find what this angle is equal to first, Then I'll be able to use the other ones to solve for the rest of the equation, the hypotenuse that we're looking for. Now there is a quick trick. Because this is a right angle triangle, technically we could use Pythagorean's theorem. We could use a squared plus b squared equals c squared being what we're looking for. We know that one side is 3 and one side is 4. So then the question becomes, what is c? So we'll keep in mind that we can use this. In fact, we'll use it as a check a little later on. But we're going to use the primary trig ratios just to show that it can be done this way. Now, solving for an angle is actually the trickier one of the two. We have to do an inverse function, it's called. Think about like moving things from one side of the equation to another. We have to move tan over. But tan is actually a function. So we have to use the inverse of tan when we move it. So when we move it over, we get theta is equal to, and it would be written like this when you go to type it into a calculator. Tan to the power of -1, and then in brackets, whatever else was there, 4 over 3, okay? Now, a calculator will understand that. What I'm going to do is I'm going to quickly bring up, here we go, Desmos. Normally I have it ready. And we're going to use tangent to solve for it. So you'll notice they have the word tan here, okay? I can put it in, but that's not the tan inverse I happen to be looking for. So I'm going to clear it, and I'm going to try, let me see the other functions. There we go. Notice they have tan inverse, so tan to the power of -1. Now what I can do is I go back to my main, and I have 4 divided by 3. What's great about this calculator is it calculates right away, and we end up with an answer. Our answer is 53.3. In fact, I think I might be able to copy and paste that. Can I paste that in here? Maybe. Oh, super cool. Okay, I'm going to go back. I pasted in my answer. Save me from trying to solve that. So theta is equal to 53.13, we'll say in this case. Okay, so it's an approximation. Let's say theta is approximately, that sign means approximately, 53 degrees. Great. So we now know that this is 53 degrees. Okay, so probably a little bit of rounding in there. So now that we know theta, I can use either of these two equations because we have more information. We have the value of theta. So we can say sine 53 is equal to 4 over h. Or I can say cos 53 is equal to 3 over h. Notice they're slightly different. It's because sine and cos calculate a bit differently. The goal here is to isolate for h. We want to find the hypotenuse. So we got to use a little algebra because it's divided by on one side. You know, I can multiply h on both sides of the equation. Over here it disappears. And then we're left with h times sine 53, which is going to be a number when we calculate it using our calculator. But before I calculate it, I want to get h by itself. So think of this as some other product or number we're multiplying by. I'm going to get h by itself. I can divide both sides by that value. Okay, I'm just going to show you this once and then I'm going to skip to doing it for the cos part on the other one, sine 53. So we end up with, over here, these cancel out. So you end up with h is equal to 4 over sine 53. This little process here that we just went through, you're going to get really quick at, and you're not going to write it all out the way I did it. I just wanted to show you that it can be done, and that's how it's done. Over here, what that means is our h, I'll rewrite it again. Cos 53 is equal to 3 over h. All that really means is the h and the cos 53 can swap positions. H will be equal to 3 over cos 53, okay? And what we'll do is we'll go back to Desmos to prove that our h's are probably approximately the same here with a little bit of rounding. So 4, so I'm going to go to my next one. 4 divided by, and in this case, I can just hit the normal sign, sine 53, and I get a value. H, oh yeah, I can copy it. It's pretty much 5. I'm just going to say it's 5, okay? And then I'm going to show you the other one. The other one was 3 divided by cos 53. And there you go. Both of them are approximately 5. And if you were to round them, they'd be equal to 5. So we're going to approximate it to 5. So we're going to go back here. And we're going to find out that, whoops, h is approximately 5. And on this case, h is approximately 5. If we were to do Pythagorean's theorem, we'd get 9. 3 squared is 9 plus 16 is equal to c squared. 9 and 16 is 25. We got to get c by itself, so we square root both sides to solve this. And Pythagorean's theorem is going to be a little more accurate on this point. These two cancel. Root of 25 is 5. C is equal to 5. So there's kind of our check, and check. We've now solved that the hypotenuse of this triangle is equal to 5. That's great. There's technically 6 variables in a triangle, 3 sides and 3 angles. I have this angle here, 90 degrees. I have this side, this side, this side. This is unknown. I could use my trig ratios, or there's a rule with triangles that makes this a lot easier. And the rule is all the angles in a triangle, so maybe I'll use theta to represent each of them. Theta 1 plus theta 2 plus theta 3. These just represent each angle is equal to 180 degrees. We happen to know that one of them is 53, another one is 90, and we'll say theta 3 is the one that's unknown. Well, we can use our algebra to isolate for that. We're going to bring the other two over, so we get theta 3 is equal to 180 minus 90 minus 53, and we get the other theta, the other angle, is going to be 37, I believe. 37 degrees. So there we go. You can use that. If you did you could use again your primary trig ratios to solve that. We end up with 30, what did I say? 3? No, it should be 37 in the end. Okay. That is